this is, I'm calling 9.0, and it's a cumulative review of chapters 1 to 3. I'm not doing a review of 4 to 6 because those are concepts that you've used throughout the whole course, and I'm not doing a review of 7 to 9 because that's stuff you just learned very recently. So this is it. This is the only review I'm making a video for. Of course, we will do questions and all the other stuff to make sure we got everything down for the final exam, but this is the only one I'm making a video for. So this is it. Last video. Enjoy. I'm not going to spend too much time going over the whys of all this stuff. I'm just going to do the hows of how to solve these things, because if you want to know why all these things are, you should look at previous videos. So the first thing you might have forgotten about is how to evaluate limits. Remember, we want to know what does this function here equal as x approaches 3. We can't just plug 3 in this case, because if we plug 3 in, we get 0 on the bottom. Can't divide by 0. So first strategy you want to try to do, try to factor. Turns out you can factor. So I'm going to evaluate the same limit. Denominator is going to be the same, but we are going to factor the top. What kind of factoring is this? Good old Bobby Bridge. So I'd be looking for two numbers that multiply to 6 and subtract to 5, which are 6 and 1. Maybe I'll just do it up here. So by decomposition, I would have 2x squared minus 6x plus 1x minus 3. The first two here you could factor out a 2x. You're left with x minus 3. Second two terms you could take out a 1. You're left with x minus 3. It worked, right? Because we have x minus 3 in both brackets. And then we also have 2x plus 1. Sure, it'd be great if we could cancel out that denominator, and we can. So now all we have to do is substitute in. So our answer would be 2 times 3 plus 1. That's 6 plus 1. So we get an answer of 7. Next one, try substitution. It won't work because when you go bottom here, you get 0. 2 minus 2 is 0. Same thing, you're going to factor again. So if you look at the top, this is a difference of squares. You'd have x squared minus 4 and x squared plus 4 all over x minus 2. And at first it looks like, well, that didn't help. We can't cross anything out. But do you see what you can still do? This first term here, this first binomial, is still another difference of squares. So we got to factor again. There's probably faster ways of writing this than I'm doing, but just to show you exactly what's happening, I am doing a difference of squares on this x squared minus 4, so x plus 2x minus 2. I can't do this because that's not a difference of squares, that's a sum of squares, and you can't factor that. That's all over x minus 2, and now we can successfully cancel this out, and we're ready to substitute in 2 plus 2 in this bracket, 2 squared plus 4 in the second bracket. So this is 4. This is 4 plus 4, which is 8. Our answer is 32. Next one, can't substitute again because you get 0 on the bottom. Can't factor either. What do you think you're going to do? Well, a numerator like this really suggests that probably what you're going to do is multiply by the conjugate. In other words, you're going to rationalize the numerator. So you're going to multiply by root x plus 4 plus 2, right? Make sure it's the opposite sign there. And what you do at the top, you also have to do the bottom. Okay, so on the top, we'd have root x plus 4 times root x plus 4, which is x plus 4. The next two terms will cancel out, right? Because we'll have root x plus 4 times 2, which is 2 root x plus 4. And then we'll have negative 2 times root x plus 4, which is negative 2 root x plus 4. And those two terms cancel. I hope that makes sense. I'm not going to write all that. Okay, then we have negative 2 times positive 2, which is negative 4. And on the bottom, now remember, what a lot of people do when you first start doing this is expanding all this. But don't. Just leave this just the way it was. The part that we want to expand is the top, because that's going to get rid of stuff. But on the bottom, just leave it exactly the same as it is. So, sorry, I should still have the same limit here. And these are gone, right? Plus 4 and then minus 4. So what we're left with, again, you probably don't need to write all this, but we have x over x root x plus 4 plus 2. Still can't substitute in because we get 0 here, but look what happens. We can cancel those out, which leaves us with 1 up on the top. So now we're able to substitute. We get 1 over 0 plus 4 square root of 4, I guess, right? Plus 2. Well, that's 1 over 2 plus 2, which is 1 over 4. And the last one here, notice this is a one-sided limit. This is just from the right-hand side. So you can still try to plug in -4, and it doesn't work because -4 plus 4 is 0, so we can't do that. There is no factoring to do. There's no complex fractions, so we're not going to get common denominators. Not going to multiply by a conjugate. So here's where you have to use some fuzzy math. So in the numerator, there's no problem. You don't have to be fuzzy about it. You can actually plug in. You get 3 times -4 take away 1, right? We're getting really, really, really close to -4. So why don't we just plug -4 in for all intents and purposes? On the bottom, you can't do that because -4 plus 4. So let's think about this. This is a number just a little bit bigger than -4. Something like -3.99999. So what happens when you go -3.99999 plus 4? Our answer is positive. It's a very small positive. Okay, so now let's evaluate the top. 3 times -4 is -12. Take away 1 is -13 over a small positive. And again, remember this is so small. This is like 0.00000000000 for a couple days, 1. So what happens when you divide -13, or any negative number, by a very, very, very small number? What kind of number do you get? It goes all the way up to infinity. In this case, it's going to be -infinity, and that would be your answer. Okay, we're going to find the limit of these two functions from the left-hand side of 6, from the right-hand side of 6, and then generally speaking 6. This is piecewise function. If we're looking from the left-hand side of 6, which one of these three piecewise functions would we be looking at? It'd be the middle one, wouldn't it? Because this is less than 6 here. In other words, the limit of f of x as x approaches 6 from the left-hand side is this one here, and in this range it's always equal to, the function's always equal to 2. So this is 2. Alright, how about if we approach it from the right-hand side? Well, if we approach it from the right-hand side, which of these three pieces would you be looking at? The bottom one. This domain here is for the right-hand side of 6. So we're just going to plug into that. The limit of f of x as x approaches 6 from the right-hand side is 14 minus 2 times 6. We can just plug that in. And if you do that, you get 14 minus 12, which is 2. Hey, look, they're exactly the same. So what does that mean about the limit of this function as x approaches 6? It means it exists, and what it's equal to is 2. So in all three cases, the answer is 2. Okay, let's do the same thing over here. The limit of f of x as x approaches 6 from the left-hand side. So that would be the top one, right? From the left-hand side is this domain here. So what I'm going to do is I'm going to plug in 6 right there. So you get 4 times 5, you get 20 as your answer. Now we're going to do it from the right-hand side. So we're going to plug into this one, obviously. So we're going to have 6 squared minus 12. That's 36 minus 12, which is 24. Okay, they're not equal to each other. What does this mean about the limit of f of x as x approaches 6? It means it does not exist. The limit does not exist. We're going to do the same thing again down here. This time we're going to do it with pictures. So we want to know the limit of this function, this red function right here, as x approaches a from the right-hand side. It says a is 0. So in other words, you could say as x approaches 0. It's probably easier to understand. As x approaches 0 from the right-hand side. Well, as x approaches 0 from the right-hand side, you're getting closer and closer to, it looks like, I know someone want to say the answer is 3, but it doesn't. Because if you get as close to 0 as you want from the side, but don't actually get there, what does it look like you're getting close to? Looks like you're getting close to -1. So that's your answer. Same if you look at this from the left-hand side. It again looks like it's approaching -1. So these are the same, which means that the limit of f of x as x approaches 0 is equal to -1. Now, what if I also asked you what f of 0 is? That means when you have an input value of 0, what's the output value in this case? The output value is 3, right? That point right there does have an input value of 0, it has an x value of 0, and the y value is 3. So don't forget about this as well. Okay, same sort of thing over here. We want to know the limit of f of x as x approaches a, but it tells us here that a is 0, so why don't we just say 0 again from the right-hand side? Okay, so from the right hand side, it's getting closer and closer and closer to 0, a y value of 0. So this equals 0. But that's not the case when you approach 0 from the left-hand side. So you approach from the left-hand side, it's getting closer and closer and closer to -4. So what does this mean about the limit of f of x as x approaches 0? It means it does not exist. Let's ask the same question. What's f of 0 in this case? Well, it wouldn't be here, right? The input, this point here does not actually exist. This one has an input of 0, and its output is also 0. How about in terms of continuity? Either one of these continuous? No, neither one of them is. To be continuous, you have to be able to draw the graph in one continuous line, and you can't do that. You certainly can't do it on this one. You have to lift your pen there, but you even can't do it on this one because you have to lift your pen to do that point there. Remember, to be continuous, this would need to be true. There had to be a limit. The limit would need to exist. F of 0 would also need to exist, and then this answer 3 and this answer here, -1, would have to be the same. And obviously they're not. So this is not continuous. Discontinuity, point discontinuity, jump discontinuity. Remember that? Remember the last type of discontinuity? Infinite discontinuity. Okay, here's something we haven't done in a while, and I'm sure you're very thankful we haven't done this in a while. Find the derivative. You might be like, yeah, awesome, 4x plus 3. But I want you to do it directly from the definition of a derivative. In other words, I want you to use the difference quotient. Don't remember that? Here's what it is. F prime of x, or the derivative, is equal to the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. Okay, ready? So this is f of x right here. So the first thing we have to do is we have to write x plus h and put that into the x's in this function. So we'd have 2 times x plus h squared plus 3 times x plus h. Then I'm going to subtract the actual function, f of x. I'm going to subtract this. I'm going to subtract 2x squared plus 3x. And that's all over h. Now you just have a whole bunch of algebra to do. So we have 2, and then x plus h squared. Well, that equals x squared plus 2hx, or xh, I suppose, whichever way you want, plus h squared, plus, distributive property here, 3x plus 3h. I'm going to distribute this negative sign, so I get negative 2x squared and negative 3x all over h. Keep going, got lots of simplifying to do here. Distributive property here, I get 2x squared plus 4hx plus 2h squared plus 3x plus 3h minus 2x squared minus 3x. Wow, all over h. A whole bunch of stuff's going to cancel, which is very satisfying. 2x squared, negative 2x squared. 3x, negative 3x. I think that's it. Next, we will factor out an h. There's an h in all three of these terms. And I'm left with 4x plus 2h plus 3 all over h. You can cancel these h's out. If I plug 0 now, I can now substitute. If I substitute 0 in here, I get 4x, because I'm not substituting to x, I'm substituting to h. So 4x plus 2 times 0 plus 3. Well, 2 times 0 is just 0. I don't need to write it. I get 4x plus 3. Now, remember how much easier this would be without doing the difference quotient? You would use the power rule. 2 times 2 is 4x plus 3. 4x plus 3, done. This is why you learn to hate the difference quotient. But it is still important. It's what calculus is really, and derivatives are really all based on. So you will be expected to know it. Okay, why not do another one? We're going to take the limit as h approaches 0 of, okay, remember we're putting x plus h wherever I see x. So the square root of x plus h plus 3 minus f of x, which is just this, the square root of x plus 3. That's all divided by h. What do you think your next move is going to be? You're going to multiply top and bottom by the conjugate. You're going to multiply by x plus h plus 3 plus square root of x plus 3. And of course the same thing on the bottom. Oh, it's a lot of writing, isn't it? Okay, so here we go. On the top, Square root of x plus h plus 3 times another square root of x plus h plus 3 is just x plus h plus 3. I'm going to write the limit here. Okay, good. Then the next two are going to cancel, right? When we multiply this times this, and then multiply this times this, those are going to cancel. One's going to be positive, one's going to be negative. So convince yourself of that. And then we have negative x plus 3, root x plus 3, times positive root x plus 3, so it equals negative x plus 3. On the bottom, again, don't expand, just leave it exactly the way it is right now. And okay, let's look at the top. I think we can just go straight to canceling here. X take away x. 3 take away 3. Let's even go faster and cancel here. We're left with h on top, and there's also an h here. So those can cancel, and the only thing left on top is a 1. And now, actually, if I do it this way, I don't even need to write the limit statement anymore. I can go straight to substitution. So I have 1 on top. I'm going to put 0 into the h, so I get the square root of x plus 0 plus 3 plus x plus 3. Well, that's the square root of x plus 3 plus another square root of x plus 3. So we have 1 over 2 square root of x plus 3. And if you were to solve the derivative in a more simpler or traditional manner, you would find you get exactly the same thing. Okay, the final question has to do with these particles zipping around. Remember, we have a position function here, so this is like where the particle is, the location of it. So the first question is, when's the particle at rest? Well, to know when it's at rest, you need to know something about velocity. So first thing we have to do is figure out the velocity. We want a function for velocity. What's velocity equal to? It's equal to the derivative of the position function. So all we have to do is take the derivative of this. Pretty easy, 3t squared minus 12t plus 9. And what we'd want to know when it's at rest, we'd want to know when this amount is 0. So we're going to set this equal to 0. As I set it to 0, I also notice I can factor 3 out. So I'm going to do that just to save some space. So I get 3 times t squared minus 4t plus 3, and we want it to equal 0. So I can disregard the 3, right? Because I could divide both sides by 3 and this would just cancel. So all I have to do is factor the bracket. I would get t minus 3 and t minus 1 equals 0, which means there's 2 times when this particle's at rest, at time 1 second and time 3 seconds. Next question, what's the velocity after 2 seconds? Okay, well, we've already done most of the work of this. Here's our velocity function right here. So in order to get the velocity after 2 seconds, we just have to know what s prime of 2 is. So that'd be 3 times 2 squared minus 12 times 2 plus 9. That is 4 times 3 is 12 minus 24 plus 9. That equals negative 3 in its velocity, so meters per second. What's the acceleration after 3 seconds? Okay, to get acceleration, what you need to do is you need to find s double prime t, or if you want, v prime t. So this was our s prime here. We got to get s double prime, take a second derivative. So no problem again, power law again. 2 comes down, you get 6t minus 12. This is just a constant, there's nothing to do. So if we want to know the acceleration after 3 seconds, what we're interested in is what's s double prime of 3. Just plug 3 in right here. 6 times 3 minus 12 is 18 minus 12. It's 6, and its acceleration, so it's meters per second squared. When's the velocity positive and when's it negative? So we know that at time 1 it's at rest, and at time 3 it's at rest. So what we need to look at is what are the velocities in these regions here. And this highlighted bit is our velocity function. So basically, if you just try any number in these regions, you'll know. So for example, if I plug 2 into here, it would tell me in this region. Well, I've already plugged 2 in here. Remember, we got a negative number. So this is negative in this. All of them are going to be negative in here. Okay, let's try something bigger than 3. How about 10? 10 squared is 100, times 3 is 300. 12 times 10 is 120, so 300 minus 120 plus 9. I don't care exactly what it is, but it's definitely positive. Between 0 and 1, like 1/2. 1/2 squared is 1/4 times 3 is 3/4. 12 times 1/2 is 6, so 3/4 minus 6 plus 9. Okay, that again is going to be positive. So there you go. Got my answers right there. What's the total distance traveled during the first 5 seconds? Okay, what I need to know is, where does this thing start? Don't forget that. A lot of people just assume it starts at 0, but it might not. I think it does in this case, but it might not. The other things we need to know is, when does this thing stop? Those are going to be important places to look at. So we already found out that's 1 and 3. So we better find what S1 is, what S3 is, and since it's the first 5 seconds, what S5 is. So we got to plug all those numbers into this one, this pink one right here, the original one. Oh boy, so 0 is no problem. 0 minus 0 plus 0 is just 0. So S of 0 is 0. 1's not too bad. 1 cubed is 1 minus, this will be 6 and this will be 9. So 1 minus 6 is -5 plus 9 is 4. Okay, 3 and 5 are a little harder. Let's go with 3. I'm going to make some notes up here for myself. 3 cubed is 27. 3 squared is 9 times 6 is 54. And 9 times 3 is 27. Hey, that actually equals 0. 27 is 54. Take away 54, you get 0 there. And 5. 5 cubed is 125. 5 squared is 25 times 6 is 150. And 9 times 5 is 45. So 125 minus 150 is -25, plus 45 is 20. Okay, so it went from time 0 to time 1, it went from 0 to 4, which is a distance of 4. Then over the next 2 seconds, from 0 to 1, it went back to 0, which is also a distance of 4. And then the next 2 seconds, from 3 to 5, it went up to 20, and 0 to 20 is a distance of 20. If you add all of those together, you get a total distance of 28 meters. And there you go. That's your lightning fast review of much of the stuff we did in the first 3 chapters of this course. Keep studying hard, get ready, final exam's coming, and your course is finished. It's been great teaching you guys this year. All the best.